We're going to look at solving distance, rate, and time problems using a system of linear equations. We have a motorboat traveling 210 miles in 6 hours going upstream. So let's think about what upstream and downstream means. Upstream means we are going against the current, right? It slows us down. So we're going to be looking at the speed of that we travel ourselves minus the speed of the current being how fast we can go upstream. Similarly, downstream is with the current. So the water helps us go faster, right? So that's going to be the speed plus the current is going to be how fast we travel downstream. So this says that we went 210 miles. Oh, sorry, rewind. That distance is rate times time, right? So we're going to use that to figure all this stuff out. So first, we have 210 miles in 6 hours going upstream. So upstream is the speed minus the current. So we have 210. Let's rewind that a hot second here. There we go. We have 210 is the speed minus the current times 6, because it said 210 miles in 6 hours going upstream. So now what I want to do here is divide everything through by 6. And so we get 35 is S minus C. Now we're going to do the same thing. It says 270 miles going downstream in the same amount of time. So downstream is the speed plus the current. So we have 270 is S plus C times 6. Divide everything through by 6. Now I have 45 is S plus C. So I have 35 is S minus C and 45 is S plus C. Couple things we could do here. The easiest thing to do, since those are exact opposite signs, is going to be to just add these guys together. So when I add them together, I get that 80 is 2S. Dividing both sides by 2, S is 40. Now to figure out what the current is, so remember S is my speed, right? Now to figure out my current, I can just plug the S into one of these equations. It does not matter which one. I chose the bottom one, and C is 5 miles an hour. So again, the speed in still water, which is my just normal speed, is 40, and the speed of the current is 5. Let's look at one more. I have some cyclists, and they are traveling in opposite directions. So I just want to think about that for a second. That means they start at the same spot and they go opposite directions, right? So first we have, we know that the speed, let's see, we have a slow cyclist and a fast cyclist, right? So I'm going to say the speed of the slow guy is X, the speed of the fast guy is Y. You could switch that around. You could call it F and S for fast and slow. It doesn't matter, okay? So one cyclist travels 7 miles an hour faster than the other. So I'm going to say that the fast guy, who is Y, is X, which is the slow guy, plus 7. And then we're talking about how they're 86 miles apart after 2 hours. And we know distance is rate times time. So the slow cyclist, it travels for 2 hours at his speed. The fast cyclist travels for 2 hours at his speed. And in the end, their total distance covered is 86. So I'm going to take that expression for Y and plug it into my green equation. So it's plugged in. Now I've got to distribute that 2. Now it's all worked out, right? I need to subtract 14 from both sides. And I also have some like terms here to combine. So we end up with 4x is 72. Then I can divide both sides by 4. Sorry about that. And I get 18. Now that I have the 18, I'm going to, that's my slow guy, right? Sorry. Now that I have the 18, I'm going to go back into my y equals equation and replace that x with its value. And when I do that, I get that the fast car is 25 miles an hour. I hope you found this helpful.